objective 7 is to simplify, add, and subtract radicals. I want to say that the main thing here is that, like, what I want to say is that eventually, when you are hearing with me, I'm usually not going to ask you to simplify stuff, because that's like some of the basic bricks for more complicated application problems. But simplifications help you make the equation look not so horrible. And the main thing about simplifying like these radicals is if you have, for example, a square root expression, anything that's a perfect square can be taken out of the square root sign, right? So basically what I say here is that we take out anything that is a perfect square. For example, I have square root of 2, a square root of 8x cubed, right? So 8 is 4 times 2, right? So I made 8 into 4 times 2. And x cubed is x squared times x. So it's x times x times x. So it's x squared times x. So basically these guys are a perfect square. 4x squared is 2x times 2x. So I take the 2x out. And then these guys stay in. This 2 and this x. This x and this 2 stay inside. And this 4x squared, I took it out of the square root sign and became the 2x that's outside. That's basically simplifying radicals. And then I have a special note saying, when we don't write anything on the square root, on the little corner, on the dip, that means it's a 2. When it's cubic root, we'll write a little 3. When there's a fourth root, we'll write a little 4, even though I don't think I've ever seen fourth root in my life. We don't really use it that much, but question? No. Okay. And then the note is, this is harder to explain, so I won't go into that, but x to square root of x is actually x to the half exponent, yeah, one like fraction. This is just a note. It might make it easier if you know that. We will see later in the future objective how to solve exponent equations with exponents and stuff. So this will show up again further. But for now, we won't actually need to worry about this much, right? Because after the pre-algebra stuff, we usually go into linear equations and stuff. Is that okay? And then here, so I have this example, which is simplify 3 square root of 20. Yeah, so we can go to the whiteboard again. Sometimes the expressions get very long, so my little thing to do this is like, now it's ended, right? I put like a little curve to protect everything that's inside the square root because it can be complicated. And then here it's like minus 5x, so it's not times square root of 18. So if you want to simplify, we do need to know some factorization. So 27 is 3 cubed, which is 3 squared times 3. 18 is 9 times 2, right? So that's also, it's 3 squared times 2. So this guy becomes 3 times square root of 3 squared times 3 minus 5x square root of 3 squared times 2. So here's something that's really important that I forgot to mention is that you can only take it out of the radical sign or the root sign if it's a multiplication. Yeah. Don't do it if it's addition. Like if this dot here is very important. It shows multiplication. If it's not multiplication, you're not allowed to take it out. So as long as you have a multiplicating factor, Then I can take 3 squared out. That will be an extra 3 here, right? And then this is square root of 3 left inside. And then minus 5x times 3 times square root of 2. So this becomes, these two can multiply out. If you have 9 square root 3 minus negative 15x square root 2. That's it. You can factor 3 out if you want. I know that, but I wouldn't. Yeah, unless required, I wouldn't do it.